we'll take you through implementing security best practice for serverless applications. And I'll start, and then midway, I'll invite my colleague Parker to take you through other aspects, and then I'll come back later to make the closing remarks. Yeah. So when we talk about serverless, we look at serverless not only to be a technology, but to be a strategy. It's actually an operating model that allows builders to be able to focus more on delivering value to the business. And you find that with serverless as a strategy, you realize that the service provider, in this case AWS, will be able to do much of the heavy lifting on various aspects of securing your workload. Things to do with patching or configuration of the network aspect is taken over by the service provider. And when building with serverless, we leverage more highly managed services such as AWS Lambda, Amazon Event Bridge, and AWS Step Function. And when you select serverless as a strategy, approach to your application architecture and even security changes, and I'll come into talk about that. Serverless, as it shifts the undifferentiated heavy lifting to the service provider, which in this case would be AWS, the common security tasks such as patching, which at times are always the responsibility of the user or the responsibility of the developers or a certain team within the organization. This basically shifts to the service provider. And when we focus, when we look at serverless strategy, then there are 4 things that we basically consider and look at from the aspect of building from a secure baseline, shifting the security operation to AWS, leveraging deep integration, which is basically a common feature within AWS services. And the last part is utilization of fine-grained access control through a service called IAM. And I'll come to that when you're managing either communication between services or basically interaction between external stakeholders with services inside AWS. What are some of the different aspects? When you build using or build serverless application or adopt serverless strategy, there are some different aspects of building and operation that we see today. But when it comes to application development, the scenario more or less looks the same. You, as a developer, you have to ensure that your data is secure. You have to write quality code and ensure that you protect it against vulnerabilities that exists. And you also have to follow what we call the least privilege principle. And I'll come deeper into what basically it means. From a difference perspective, you realize that when you talk about serverless architectures, when it comes to providing access control, it's majorly defined through an IAM service, Identity Access Management Service, and that is the service that you'll use to provide fine-grained control access, whether it's for communication between services. And then the development toolings that comes with it and artifacts tends to be different from the normal approach that you probably have been using. The other thing that we also see that security is not a responsibility that might be residing within a specific team within an organization. Security is a shared collaboration between different teams within organization. You have a security team, you have platform builders who are actually responsible for security when you adopt serverless strategy. And then we also have development team who in most cases are responsible in basically providing the application code. But when you come to serverless strategy, then infrastructure can also be provided or is basically provided by the dev team, which is basically delivered through infrastructure as a code. The question that always comes to mind is, as much as serverless strategy spurs innovation, do we need to trade off security with this? And the answer is you can continuously innovate and at the same time ensure that you are innovating with security in mind. And this is made easier by the aspect that when you look at cloud, the ability to be able to automate most of the security operations easily makes it easier to be able to continuously innovate as you also think of security as an aspect of building your application. And serverless allows you to be able to focus in innovation where you deliver value to your customers, but also ensuring that you have security at a level that does not compromise the development that you've built. Now, how then do we secure serverless applications? Application security within the serverless strategy touches around 6 areas. We have injection vulnerabilities that will be able to look at how do you deter injection vulnerabilities or common attacks. Excessive privilege, how do you manage and ensure that the privileges that are assigned to your developers does not allow them to, for example, escalate and be able to assign themselves more powers to do things that are not required. Then credential exposure, that's an area that my colleague will be able to talk about. Unbounded requests, sensitive data exposure that you might have within your environment, and then issues to do with rate limiting. So before we go into looking at all these areas, let's take an example of what a serverless architecture would look like. This is a classical case of building a serverless architecture. I've taken a very simple microservice architecture, just basically to demonstrate. And you can see we start from the infrastructure definition and application code development as basically what fits into the serverless architecture, and that becomes the responsibility of the developer. Then at the back end, we have endpoints. And in this case, we have an application, Amazon API gateway as an endpoint, which then connects you to backend services. Here we can have Lambda functions, basically if you're running on a serverless strategy. And then the Lambda function basically either sends data to a data storage service like DynamoDB, or actually calls for another private API endpoint to another service. What is important at this point is that there has to be responsibility that's assigned to different teams within the organization to ensure that you implement security within the serverless application architecture. Now, having looked at that architecture, let's look at how you can be able to protect against injection attacks. The first aspect of this is to be able to validate any untrusted event payload that hits your API gateway. This can be either contained in the body, it can be on the query string, parameters of the header, or it can either be both on the body or the query string. And we can configure our infrastructure as a code, like I've explained, or using open APIs in order to be able to continuously validate any untrusted event payload that comes into the API gateway. If the validation fails in this case, then the API gateway will not be able to pass that. Again, the other thing that's very important is also to be able to test the validation and so test passing, and I'll be able to come to that in a short while. The other aspect is to be able to protect your endpoints. And if you look at the mechanisms to be able to, the mechanism that you deploy to protect your infrastructure, there's a concept called defense in depth. What defense in depth means is that you basically try to move away the attack surface very far away from your application to the periphery. And this is one way of actually implementing defense at depth, where you use a service like AWS WAF, Web Application Firewall, to be able to do filtering at the edge before any request basically hits the API gateway. And you can be able to defer against common attack vectors such as SQL injection, cross-site scripting, or command injection. In this case, you can see that when it comes to protecting the API endpoints with WAF, that becomes the responsibility of the security team and the platform team, and not the developer. If you look at, again, validating untrusted event payloads at the API gateway, that's also responsibility of the security team and the platform and not the developer. Now, when you come to validating event payloads, which is also another mechanism, this now becomes responsibility of the developer. And we recommend, again, that you have to validate all untrusted payloads. The other thing that we highly recommend is that try to separate both the input validation from passing and continuously test each separately. What is it that passes validation or fails, and what is it that passes passing itself and also fails? And AWS Lambda has capability to implement that through Power Tools for Python that has a utility that you can be able to use to simplify validation. It basically uses JSON schema, and you can basically be able to validate this using very simple steps. The other aspect of validating payloads with Lambda is to consider strict typing. If you're using AppSync or GraphQL, they basically offers strict types. And API Gateway also do provide request validation. The other thing that we can highly recommend as part of the validation is to try to avoid single parameters accepting more than one data primitive, because that also can result into some issues. And you can see when you look at now validating the event payload in the Lambda, that becomes a functionality or a responsibility of the development team. The second aspect of what we're going to look at is list privilege. The concept of list privilege is quite interesting. Now let's look at a serverless developer work product. Remember, when you look at the architecture, we had the application code, we had the infrastructure definition, and then we have an API gateway and a Lambda function. The developer basically delivers a set of application code that can be written into Lambda functions. Infrastructure definition using can be written in AWS CDK or CloudFormation. You can also use AWS SAM or Terraform or any other tool of your choice, and you find that these are always defined by the organization. In most cases, the developer should be having the privileges that allows them to be able to perform their function. That is the concept of list privilege. Now, what it means is that during the building of the function, the application code, and the infrastructure definition, and also definition of the Lambda function, then the developer can also be able to create what we call the execution role, the function execution role, which allows the Lambda function to be able to access other services. Like in the architecture, you saw that Lambda is either sending some data to DynamoDB or calling some other endpoints that are private within your application domain. And for Lambda to be able to communicate with those other services, you need to have a permission set defined within the execution policy, the execution role policy. And as we do this, what always happens is that developers might tend to provide what we call either a blank privilege, that's a super privilege that allows anything to be done, and that's basically what we discourage. So if you look at the concept of list privilege, we have to set the permission. You have to continuously verify the permission, and after verifying the permission, you can be able to refine it based on what you are actually seeing. But what list privilege does, again, like I've said, is that just provide the right permission for the intended work, not anything extra. And in most cases, ensure that you have a proper definition of what the role needs to do and limit it to what the role needs to do. Again, this basically becomes in management of the least privilege permission set. This is basically a functionality that is performed by the development team. How then do we ensure that developers don't become cheeky and escalate their privileges? One aspect of doing this is what we call using what we call the permission boundaries that are basically attached to the roles that you create, and their main action is to limit the breadth at which that role is supposed to operate. You basically limit the actions that a role that you've created and attached that permission boundary to can be able to do. And we do hear a lot of concerns from customers saying that developers have a tendency to be able to potentially overprivilege their roles or policies that they create. And this is one way of actually being able to limit how limit the possibility of a developer escalating their privilege. What happens with again, common scenario that we see is that developers build applications on the test environment. It works because at that point they probably defined very escalated privileges. They're using things like star to denote everything is allowed, every action is allowed, every action can be taken on any resource within the role that they're defining or the permission set that they're building. This is not least a privilege because it allows anything to go through. So as much as that can be done on testing, you never want this to go into production. And that's something that you have to be very careful about. So let's take a deeper look at a role that's assigned to a developer. This can either be assumed via any IDP store that you have or any other some other means that you're using. And in this case, the intention is basically to allow the developer to become innovative, allow flexibility for them to be able to conduct their work. But you also, in order to limit that, you're also going to attach a condition on their ability to be able to either create or to attach policies to the roles that they create. And this is the concept of boundaries that I was actually talking about. In this case, the developer will be able to create roles under certain circumstances. And in order to limit the extent to which they can be able to escalate their own privileges, then you'll be able to require a permission boundary attached to any of the roles created before that role is created, failure of which then they cannot be able to create that particular role. So if you look at an example here where we have a function that will try to delete some table on a DynamoDB. Let me just go back. If you look at this particular template here, we have an allow action, and you can see the privileges are assigned to DynamoDB. So we want to see how then you can be able to stop escalation of privileges by some developer. So in this case, the policy is already authored, like you've seen. So we have a policy document that contains the same content that I've shown you. And then using the developer role that has limited permissions, but allows them to be able to create policy, they'll be able to try to attach a policy to a role. But in that case, they won't be able to, they'll try to create a policy, but they won't be able to do that because they need to attach a boundary, a permission boundary role to that policy. But again, even after attaching that permission boundary role, given that they want to delete an item from a table and that was not defined, they won't be able to do that. And that will basically bring an error. So if you look at the way effectiveness of permission boundaries do happen, is that you can see there we have permission. We have the permission that was defined and the developer created role. But if you look at the common point, the intersection point, you have only a put event, a put action that can be performed on the table. And deletion of an item is not basically defined. That's why the role was basically failing to do that, because permission boundary has been set. And if you look at that, we have only put items, and there's no deletion that is defined. The other aspect on which you can be able to limit the control and implement some level of least privilege is using what we call service control policies. And in cases where you have multi-account strategy, you have an organization with different accounts within that organization, you've created other organizational units within the organization, and you want to control what happens at account level or at an organizational unit level, then service control policies is the way to go. The difference between the two is that the permission boundary works within the role itself that is either attached to a user or attached to a resource, and service control policy works at an organizational level. And service control policies, they don't allow, they only deny. So as you can see here, you apply it to your organization. You can apply them to the root level of the organization, or you can apply them to any of the specific account levels, accounts that you have, or organizational units that you have within the organization. If you look at this policy here, it's basically saying that you can create functions, but you must actually provide a tag, an owner tag, and in the event that you don't provide that owner tag, then you can't be able to create that particular function, and that's quite implementable at service control policy, basically at the either account level or at the root level or at the organization level. Again, this becomes the responsibility of both the security and the platform team within the security team that you have in your organization. You can also be able to use that to prevent creation of public APIs, gateway endpoints, and you can use service control policy. This is just another example where you're using a service control policy to restrict permission from an IAM user and a role within an account, including the member account within the root within the member account to be able to limit on how they can be able to create publicly accessible API endpoints. And you can do that at account level to limit what can be done by either developer or any other user within that account. Now, when you use both permission boundary and SCP, then the permission boundary, the service control policy, and identity-based policy must allow the action, failure of which that action will always be denied. Again, you can see this is the responsibility of the security and platform team. Going to the next one, I'll now invite my colleague to be able to take us through the next ways on how you can be able to implement security within the serverless strategy or architectures.
Thanks, Cedric. Hi, everyone. My name is Alton, and I'm also a solutions architect at AWS. And in my role as a solutions architect, I work with different customers across different industries, and pretty much help them adopt security best practices when it comes to AWS. And for this part of the session, what we're going to be doing is we're going to be looking at the different ways in which you as a customer can prevent against credential exposure. And at the heart of that, we're going to talk a little bit about AWS IAM and some of the features and controls available to you as a customer. This is not going to be a dive deep into the AWS IAM service, but we're going to have a look at, at a high level, some of the controls that are available to help you as a customer secure your serverless applications on AWS. All right, so before we can start talking about the different, IAM controls that are available to you as a customer, it's important to understand the different ways in which we interact with AWS, right? And the first one I want to talk about is your control plane actions. So what do we mean by that? So these are your management actions, right? So, and this can be something like, I would like to create a Lambda function. I would like to create an API gateway. I would like to update my state machine. So those are management type of actions. That's what we call your control plane actions. Now, why is it important to understand this? Once you start thinking about AWS IAM and the different IAM controls that you can implement, right, to secure a serverless application, you then start thinking about who can perform these actions and where can they actually perform these actions. Now, a typical example is with a developer with access to a dev account. In that sort of controlled environment, you would typically, allow, developers, flexibility in terms of performing those actions. They're building POCs, they're building prototypes, so you want them to have the flexibility and, create Lambda functions. You want them to, run wild, not too much, but you want them to have that flexibility. But as you move to production, you want to start thinking differently about that, right? You want to maybe look at, implementing a CI/CD pipeline, automating your software delivery process when it comes to, pushing your code into production. So for that particular situation, you would look at, an IAM role, right? And your CI/CD pipeline would pretty much have those permissions to do, those management type actions in your pod account. And another approach I want to talk about is your data plane actions. So these are your everyday sort of actions that your applications, actually, does. So if you think about the simple architecture that, Shadrach shared a couple of slides ago, you had API Gateway, you had Lambda, and you had DynamoDB. What happens is that a client hits your API, a request is sent to your Lambda function, right? That interaction, API Gateway is actually invoking your Lambda function. So those kind of, actions happening in your applications on a day-to-day basis, we call those your control plane actions, or rather your data plane actions. And obviously, likewise, Lambda functions would then, speak to or interact with different AWS services, right? And again, you then start thinking about who can actually invoke my Lambda function, right? In that particular architecture, we saw the function was interacting with DynamoDB. You have your sensitive information there probably, right? And you want to make sure that, that function, right, has the appropriate permissions, right, to interact with your database. So this is, the kind of thinking that, we sort of, recommend for our customers when it comes to, thinking about, securing their serverless applications. We're going to talk a little bit about, some of the controls. Shadrach did touch on a few, but we've got, SCPs. He spoke a little bit about, permission boundaries. We're going to have a look at, VPC endpoint policies. So these are different, IAM controls that are in place that you as a customer can use today to secure your serverless applications. So the first one we want to talk about is, securing a Lambda function, right? So Lambda is it's a major component when it comes to, building serverless applications on AWS. Arguably one of the services that kickstarted the, serverless, revolution, right? And when it comes to securing your Lambda functions, you have two options, or rather you have sort of two controls that you need to understand, right? And the first one is a resource-based policy. So this, going back again to that example that, Shadrach showed us, where you had an API gateway with your Lambda function, right? API gateway will invoke the function, right? So what you have in your resource-based policy is you define who can invoke your function, right? I've had, a lot of, situations, working with customers where resource-based policies weren't configured properly and anybody could just, spin up your, Lambda functions. And, most of you probably know that Lambda, obviously you can run, different instances of your function, right, at the same time. So it was a situation of, having, massive costs because security wasn't, put in place. So resource-based policies pretty much, give you that ability, right? You get to control who can invoke your Lambda function. Now, Lambda being a major component, as mentioned, you're going to have a situation where it will interact with, a lot of, AWS services and even downstream other, endpoints. And what you want to do there is you want to use what we call an execution role, right? Shadrach did touch on this a little bit, but the idea here is you pretty much define, the permissions, right, that the function should have when it comes to interacting with the different, AWS services, right? Shadrach spoke about least privilege. If your Lambda function is interacting with DynamoDB, right, if it's interacting with just that one table, what you would then do, applying the principle of least privilege, you would define the permissions that that function just basically needs to communicate with DynamoDB for that particular table. So when it comes to, securing, Lambda in terms of, the interactions, right, that it has with the different, AWS services, these two IAM controls, become super, super important because they provide that layer of security when it comes to your Lambda functions. So again, another component that is, super important when you start thinking about, your event-driven sort of, architectures. You've got, Amazon Event Bridge, right? And again, we see the same concept, right? A resource-based policy and an execution role. And here, think about a typical example where you have a multi-account strategy, right? And in your sort of strategy, you have that one single account where you deploy your event bridge, and all these other, accounts pretty much, push messages to that central account. So in a situation like that, right, again, you want to have a little bit of control, right? You want to be able to sort of, control who can actually push messages to an event bus in this particular account. So that is where the resource-based policy comes into play. You can actually, lock it down and specify the different accounts that you want to interact with your event bridge. And obviously from that point onwards, when messages, get to event bridge, there's a scheduler, and according to the rules that you've set, what happens is that those messages are then sent through to the different endpoints. And those endpoints, could be, a Lambda function, right? That's where, again, the execution rule comes into play. You define, right, what event bridge can actually do, right? If it needs to invoke a Lambda function, you have those permissions there. So it's very, very similar to, how you would, secure a Lambda function. In a nutshell, that's, pretty much how that works. All right, so for your persistent layer, right, we're going to use DynamoDB, right, for the sake of the conversation, right? And, we talk a lot with customers when it comes to, the security of data, right? And the first option there, right, is always use AWS IAM, right? More specifically, IAM roles, right, to access your databases. But we've got a situation where, most AWS databases, do support, AWS IAM, but there's some, that, that don't have support for AWS IAM. So with AWS IAM, when you connect to your database, you pretty much request for what we call temporary credentials, right, from AWS IAM. And with those temporary credentials, you're able to assume a role. That role will have the permissions that you need to interact with that database, right? So again, when we don't have, that that solution for other databases, right? What we tend to see is, obviously, the other option is, connecting directly to your database, right? Using your database credentials, and typically you would see this, with customers connecting or using the Lambda function to, connect with those databases. We've seen, a lot of horror stories where, those database credentials have been, hard-coded, right, into the Lambda functions. And that code has actually been, committed into, repos. I don't need to talk about, the consequences of that, but it's something that, we should never, ever, do. And I will talk a little bit about, for that particular situation, what you can look at in terms of storing your sort of sensitive and username and passwords for accessing your database in a secure storage and calling it when you need it. So that service is something we're going to get into in a bit, but it's AWS Secrets Manager. We're going to get to that in a little bit. The other option I want to talk about is when, again, you have those databases that don't natively support AWS IAM, you have an option to create an API and pretty much, place it in front of your database, right? This is, again, a good solution because you pretty much take advantage of the IAM or security controls that API Gateway supports, right? So AWS IAM roles would be supported for your API. You'd also have the ability to use authorization, JWT authorization. You have a Lambda authorizer that pretty much uses or that checks, a JWT token to check if you've got permissions before the request is actually allowed to hit your database. You can also use API keys. It's a good solution, but we do understand customers, would have, those use cases where latency is a big, is a big concern. So placing an API in front of your database, it's another hop, right? And again, the conversation around security and performance, right? it's a conversation that has been happening, for quite a number of years in the industry. And again, it's just about finding the right balance, right? So what I want to talk about next is Secrets Manager, right? And how this works is that, as mentioned, you have a secure storage where you can store your credentials. We call them secrets, right? So these are your sensitive information that you don't want, getting exposed, right? So in a situation where you would like to, connect directly with your database, right? How that typically works is that your Lambda function would make an API call to AWS Secrets Manager to get those credentials. And once it retrieves those credentials, it can then establish your connection with the database, and from there you can communicate with the database as you would normally, right? Now, there's other considerations when it comes to, that sort of, architectural solution. And it's important to also understand how AWS Lambda as a service manages, your functions, right? So when it comes to your functions, getting invoked, how that works is that the AWS Lambda service spins up a container, right? So the amount of time it takes to actually spin up that container. So let's say we have a Java, function, right? So obviously the service needs to, initialize, a container with all the dependencies and packages. The JVM must be running so that we can compile our code, right? So the amount of time it takes to spin up that container is what we call a call start, right? Now, once the container has been spun up, subsequent invocations will run in the same container. So you have container reuse. So subsequent sort of invocations become a little bit faster, right? Hence the term call starts, right? Now, setting that foundation, right? It's sort of important to understand how that works, because it can inform your decision in terms of at what point should you be fetching your credentials, right? And the best practice here is we want to make sure that when the container is actually, initialized, right, we want to pull all the dependencies that we need, right, including fetching our credentials from Secrets Manager, so that these are preloaded into the container. If we don't do that, we have a situation where if every time the Lambda function runs, it will make a call to AWS Secrets Manager. Again, a delicate balance between, having performance and security. So that's pretty much how, AWS Secrets Manager works. Provides that, a secure storage for your secrets. All right. So going back to the conversation around call starts, right? Call starts have been a major sort of, issue for customers, right? We've gotten, a lot of feedback from customers, and customers have been telling us that they would like us to sort of, look at a better way to handle, Lambda functions, life cycles, right? As mentioned, the amount of time it takes to spin up the container, that's what we call a call start. And it depends on the language that you're using. As mentioned, with Java, JVM must be running. But with Python, you'll find that the initialization time is actually a bit less, because Python is an interpreted language, right? So it depends on a lot of factors, right? And also it depends on the number of dependencies that you're pulling as the container is getting initialized. So what we sort of looked into is a separate process, and we call this a Lambda extension, right? So how this works is that you pretty much offload the pulling of, dependencies, packages that you need for your Lambda function to a separate process. So this process pretty much, runs at the same time as your container. So it's responsible for pulling those packages, and it exposes those as an endpoint in the same sort of environment as your container. So in your code, you would just pretty much, fetch, whatever resources you need for memory, and Bob's your uncle, right? That's pretty much how it works. So this is a solution to sort of, combat the whole, decisions around, do I pull, my secrets when the container is getting initialized, or do I do that each time, the Lambda function sort of, needs to run? So really, 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 cool solution. Like I said, separate process that runs concurrently with your container, and in your code, you just, pull your resources as you would normally. All right, so moving right along, for this part, we're going to have a look at the different ways in which we can sort of look at locking down access to our serverless applications, right? And allowing authorized, applications only to hit, our backend, right? So again, going back to the architecture, right? Very simple architecture, API gateway, Lambda, DynamoDB, right? When you hit your API gateway, the request hits your Lambda function, and from there, the Lambda function interacts with the database. What we want to do now is we want to make sure that we don't just accept every request, right? And from an API gateway sort of perspective, you've got a bunch of options, and we're going to talk a little bit about those in a bit more detail. But essentially what we're trying to do here is we're trying to look at options in terms of how do we get a client to sort of identify themselves and give us some sort of information that we can use to determine if we should allow them to access our application. So that's pretty much what we're trying to do here. So API Gateway does support a bunch of options when it comes to OpenID Connect. So that would mean that as a customer, you pretty much authenticate yourself with an identity provider. You get a JWT token back, and from the API Gateway will inspect that token and ensure that you've got the right sort of scopes and claims in that token. And based on that, we either deny or allow your request to hit our database. So going into a little bit more detail, what you see on this architecture, right, is a bit of an extended architecture where we're introducing a service called Amazon Verified Permissions. And what Verified Permission does is it offloads the authorization bit, right, from developers, right? How it works is that it allows your security teams to actually define a policy, right, for authorization. So it uses a similar language to AWS IAM, but it's a specific language called the CEDAR language, and it's open source. You can have a look at it. But essentially how this works is that, again, you authenticate yourself with an identity provider, you get a JWT token back, and once it hits API Gateway, you have a Lambda authorizer attached to your API. That Lambda authorizer takes that token, it sends it through to Amazon Verified Permissions. It then decides if it should allow that particular request based on the information in the token. So here's an example of what that policy would typically look like. So essentially what we're trying to do is we are looking for this particular sort of claim in the token, right? If this user is, it belongs to a particular group, in this case, the group is developer, we can allow the particular user to hit, to make the get, request against our API gateway. So that's pretty much how it works. You define this policy, and Amazon Verified Permissions pretty much does, the rest for you. It offloads the burden of authorizations from developers. You can have your security teams actually write these policies, and because they're the right people to be looking into these sort of things. Not to say that developers shouldn't, but the security teams, would have, full access in terms of, setting these, controls for your applications. Right. So the next part that we're going to get into is how do we, go about preventing unintended access, right? Understanding how we're going about doing this, it's important to, touch on the AWS, shared responsibility model. This is where we as AWS, we have a part to play in terms of securing the infrastructure that runs your application. And you as a customer, you also have a responsibility to secure the applications that you're building on AWS. So we're going to have a look at, we're going to have a look at some of the controls that are available to you when it comes to, that portion. And the first one I want to talk a little bit about is, encryption, encrypting your data at rest. So these are the different options that you have. We're going to, have a look at, one or two. And the first one I want to talk about is the ability to encrypt your environment variables in the Lambda function. So environment variables is, again, another topic where if you go back to the database, conversation, you can actually store, some information, right, in your environment variables, right? But there's also a risk there, right? If somebody gets a hold of your Lambda function, they have access to your environment variables, right? You could store your database credentials there, right? What this feature allows you to do, it allows you to pretty much create an encryption key using Amazon AWS KMS. Using that key, you are able to encrypt the data in your environment variables. And the other feature I want to talk about is the ability to import your own key. right? For customers in highly regulated industries, this is a big, big, big concern, right? Being able to bring your own, encryption keys to encrypt your data. So those are the two ones I just want to, touch on for this part of the section. And for your network layer, we have AWS Private Link. And what this does is it provides a secure private channel between your VPCs, right? And what you see on the screen is a very simple architecture where you've got different clients in one VPC wanting to access your API endpoints in, a different VPC, right? I mean, typically you would probably look at, going over the internet, right, to access, those API endpoints. But again, with API Gateway, you do have that option to create your private APIs. And what that allows you to do is it allows you to set up AWS Private Link. And through AWS Private Link, you're able to provide a secure channel and a private channel between your two VPCs. And the other one I want to talk a little about is looking at protecting your front door, right, for your public APIs. AWS WEF, Shadrach spoke a little bit about it. Essentially what this allows you to do is you are able to, it behaves pretty much like a firewall, like a traditional firewall, where you have your rules, right? Your firewall rules, you can sort of, restrict traffic to, specific, IP addresses. If, you've got, bad IPs that right? You can pretty much, flag those and block traffic from that particular sort of, IP addresses. You can also, do rate limiting, right? You can restrict how many requests, hit your API as well. So those are different kind of rules that you have available. And the other one I want to talk about is being able to sort of, mask sensitive data. Again, this is, looking at customers who are in highly regulated industries where they need to be PCI compliant, they need to be, HIPAA compliant, right? You want to make sure that sensitive information doesn't pass through your application, right? And for that, you can use SNS. SNS is a data protection feature where it allows you to define identifiers. So it's basically a regular expression. So how it works is that when sensitive data passes through your application, it will go through the SNS topic, and that identifier, that regular expression, will pretty much detect sensitive information. And from there, you can take action in terms of, do you want to block this, or do you want to, mask, that data? All right. So when it comes to platform considerations, right? Here, what we want to think about is we want to think about a multi-account strategy, right? And we want to use this multi-account strategy again to create boundaries, right, around our environments, right? I made an example about having a developer in a dev account, right? If something happens, obviously you would have given them, permissions to run your management type of actions. If something happens, right, in that environment, right, you can control the blast radius, right? But obviously, as you move to production, right, you automate that, less risk of, having something go wrong in production. So best practice here, using AWS accounts as a form of boundary around your AWS resources. And again, what you want to do is you want to also have a look at the different features when it comes to securing, right, your sort of development life cycle, right? So as you're pushing code to production, right, you want to have a look at some of the controls that you can use. And I'm just going to go quickly through some of those options that you have today. So Amazon Inspector, how it works is that it pretty much scans your Lambda function, right? So if it happens that by mistake, you hard code credentials inside your Lambda function, Amazon Inspector will be able to pick that up. If it happens that you're using a package that has a CVE, Amazon Inspector will be able to pick that up. Another one I want to talk about is Amazon Guard Duty. How this works is that it detects anomalies when it comes to traffic patterns. So if it happens that somebody gets a hold of your Lambda function and they start making API calls to different endpoints, what's going to happen there is that Amazon Guard Duty will be able to pick those up and inform you so you can take action. And all of that, right, can be sort of, viewed on a single sort of, dashboard. And that is something that, Amazon Security Hub provides a single pane of glass where you can see all your findings, where you can do your triaging, and take your next steps when it comes to resolving those recommendations. And with that, I'll hand back to Shadrach to close off for us. Thank you.
Thank you. I know we've actually run out of time. Just to close, remember this, very important. Security is a collaboration across your teams. We have security team, we have platform builders, we have development teams. We demonstrated how each and every team is responsible and what they're responsible for. Please remember that as you go develop on AWS. Again, the principles of serverless security: implement least privilege always. And we prefer that you use IAM for fine-grained controls. Apply defense in depth, and we've demonstrated how you can be able to use services at the periphery to limit what comes into your application domain. Leverage deep integration across AWS services. AWS services are deeply integrated. We do have services that are purely meant for building security and implementing security. Please take advantage of that deep integration. And then the last one, automate security. It's very, very important. Eliminate human interaction, eliminate human touch points, and create more of automation, because that will be able to enable you to scale and to operate at scale. With those, thank you so much. We kindly ask you that if you want to continue learning about serverless architectures and strategies, please click on these links and you'll be able to learn more. Thank you very much, and really appreciate your time.